Successful and safe instrument maintenance requires knowledgeable staff, the right methods, appropriate appliances and materials, good aseptic practice, and correct personal hygiene. After the operation or procedure, dirty instruments will be placed in a trolley and transported to the sterile supply department washing facilities. Instruments treated in the washing and disinfection equipment in hospital wards must also undergo further processing in the sterile supply department. As the instruments arrive at the washing facilities, their status and location is registered in the Sterile Supply Department's data system. The instrument circulation management system is used to support the work of the instrument technicians. The data system documents and reports the movements and location of instruments and provides reports on the activities of the Sterile Supply Department, such as the number of actions performed, processing times, and product expiry dates. The data system can also provide instructions on how to dismantle or how to correctly wash an instrument. Instrument maintenance requires water, both when washing the instruments and when using steam for sterilization. Good quality drinking water is not the best option for sterilization. The quality of the water used is established by water analysis, which determines the equipment needed to treat the water. The first stage of the process consists of sanitizing the pipes and equipment with a small water disinfection unit. The water system contains many impurities, such as rust, sand, and manganese sludge. As repair work is performed on the pipes, these impurities can become dissolved in the water. The purification of the water starts with a particle filter, used to remove the coarsest particles. A self-cleaning 90-micron filter is suitable for this purpose. For washers, steam autoclaves and steam generators, serious problems are caused by calcium buildup. A resin pulp that looks similar to fish roe binds any hard elements in the water. The hard water can also be softened using hot water. Softening the water speeds up the washing process. Resin should be regenerated periodically using extra pure sea or mountain salt. The system has a separate saline solution container for this purpose. The softening of the water has a direct impact on the washing result, and the amount of cleaning agent used is significantly reduced. This also means that rinsing agents are not needed. Chlorine residue is removed with an activated carbon filter, and the finest dirt particles are eliminated via microfiltration in order to prevent damaging membranes in the reverse osmosis equipment used in the next stage. Harmful salts that crystallize on surfaces when water is heated are removed using the semi-permeable membrane of the reverse osmosis equipment. Using mineral-free water is best for rinsing. An aseptic funneled vessel with a washing ball, air supply filter, and a surface level adjustment system supplies water to the washers, autoclaves, and the pure steam generator. Instruments and baskets must be carefully placed on the washing shelves, allowing the spray nozzle's full reach throughout the load and the chamber so that all surfaces are cleaned and disinfected. The instruments are then assorted manually, making sure that none of the joints are closed. A variety of different washing accessories is needed for certain instrument groups, including wash racks for tubes and endoscopic surgery instruments, enabling efficient flow of water through the channels and cavities of the equipment. Ultrasound washers may be used to wash difficult-to-clean hollow instruments. Not all instruments used in operations can be processed automatically. Equipment that requires manual treatment includes battery-powered drills and saws. Risk of infection must be eliminated before manual washing. The instrument shall tolerate disinfection by immersion. If necessary, the instrument should then be washed in a solution that is prepared in a basin according to instructions. The instrument is flushed thoroughly, using running water to carefully rinse off the cleaning agent. Manually washed instruments are dried before delivery. Any blood stains and other secretions are removed and the working surfaces disinfected. Empty trolleys are taken to their designated washing station, where they are washed and disinfected. The selection of cleaning agent is influenced by the type of soil, the properties of the water used, and the required washing result. Before starting the cycle, check the amount of detergent. The cycle does not start unless volume of detergent is sufficient for the chosen cycle. When using the same cleaning agent, it's simple to replace an empty container with a full one. If a different chemical will be used, the pump dispensing the cleaning agent shall be rinsed with water in order to prevent mixing and possible sedimentation of the substance and resulting blockage in the pump. The dosage of detergent must be monitored regularly. The correct volume also depends on the quality of the supply water. The dosage of the chemical can also be monitored by manually testing the volume intake by the washer. In new washers, conforming to the most recent EU standards, the volume of cleaning agent is measured by the washer's own flow meter. The volume value can be pre-programmed individually for each cycle. 1 or 2 final rinses should be performed with RO water, produced with reverse osmosis equipment, making the rinse more effective and keeping the inside of the washer clean and shiny. Each wash begins with a cold water rinse to prevent proteins from coagulation on the processed instruments. The next stage involves washing with detergent and warm water, then a rinse, disinfection and drying. The progress of the cycle can be monitored on the screen of the washer disinfector, displaying the remaining time to complete the cycle, the name of the cycle and batch number. There are also options for viewing the temperature and pressure curves live in the display. EU standards determine the functions of washer thermal disinfectors, but the user must define the level of documentation and monitoring used. The time and temperature for the disinfection process are also based on the EU standard, establishing a temperature at 90 degrees Celsius and a duration of 1 minute as the minimum norm. This eliminates organic microbes so that they are no longer able to cause infections. If there is a malfunction in the washer disinfector during the cycle is suspended and the machine begins troubleshooting. An error message is displayed on the screen, which helps the user to identify the location of the problem. Any defects should be repaired only by a qualified professional. In the case of a malfunction, instrument washing shall be completely restarted. With the introduction of new EU requirements, the washing process has been given greater emphasis in the work of instrument care. Sterilization will not be successful unless the instruments are first cleaned and disinfected. Users must be able to monitor the machine functions and regular maintenance must be performed. It is the duty of the users to keep the washer disinfector clean. The wash arms and the bottom sieve shall be cleaned regularly, the delicate rotation of the washers kept unimpeded, and water inlets and outlets cleaned. A log shall be kept of all monitoring and maintenance work performed. This will help ensure a high-quality cleaning result, increase the machine's working life, and help reduce malfunctions. Once the washing and disinfection cycle is completed, open the door on the clean side and remove the instruments from the washing chamber. An overall check is performed on the result and the cleanliness of the instruments. A variety of different indicators can be used to monitor the outcome of the cycle. When the instruments are visually clean, the end result can be deemed acceptable. When the cycle is complete and the machine has been unloaded, a printout will be produced for you to verify that the process was completed satisfactorily. In addition to data on the machine and the cycle, the printout provides information on who initiated the cycle and when, together with the batch number. The drying phase available in the washer disinfectors can be skipped when separate drying cabinets are being used. The baskets are removed from the washer and placed directly onto the shelves of the drying cabinet. The temperature in the drying cabinet is kept stable, meaning that no time is spent on heating the cabinet. The air used by the drying cabinet is drawn from a pure source and directed through an HEPA filter to ensure that the drying process does not compromise the washing disinfection result. Once the baskets and the instruments are dry, the cabinet is emptied and the baskets are transferred to packaging surfaces. Packages and sets are then prepared for future procedures. When the code of the product treated is scanned, the data system identifies the item in question and its status in the process. Ensure the cleanness and functionality of the instruments. The contents of the operating room tray are checked using a checklist. The system can also provide guidance in assembling instruments with various parts or regarding measures to be carried out at certain intervals. A product label is printed out for the product, including the option of a contents list. The label can also show information on any product irregularities. After they have been inspected, the instruments are packed in the appropriate sterilization packaging, which enables the product to be sterilized and to maintain its sterility during transport and storage right up to the moment it is used. And the packaging must also allow aseptic opening at this point in time. When selecting the packaging material, the following aspects need to be considered: the size of the product, its intended application, packaging and shipping, and the required shelf life. Both the instruments to be packed and the packaging materials have to be checked as to their suitability for the specific sterilization method involved. Various specially designed heat and moisture-resistant packaging systems are available for autoclaving. Certain packaging materials have been developed specifically for low-heat sterilization. One of them, Tyvek, resembles paper but is in fact 100% synthetic. Paper laminate packaging is an easy-to-use and cost-efficient solution for packaging individual instruments and relatively small instrument sets. The packaging is made from special paper, which meets healthcare purity and quality standards, and a highly durable multi-layer plastic film. Thanks to the transparent film, the products inside the packaging can be easily identified, therefore reducing the need for additional marking and labeling. The sterilizing medium, such as steam, will penetrate through the paper to the inside of the package. The exceptionally strong paper is waterproof and maintains its strength even when it's wet. During the vacuum pulses applied in sterilization, excess air escapes from the package through the porous paper that also enables the sterilizing medium to pass into the package. The quality of both the paper and the laminate has an impact on seal strength and fiber-free opening. The shapes and sizes of instruments treated in sterilization units can vary. An open-ended roll stock pouch provides a flexible option for packaging long instruments. This enables the person preparing the packaging to determine the length needed. When measuring the size, it's important to allow extra space for sealing the package and also for a flap with which the package can then be easily opened. Disposable sterilization wraps provide an easy and safe alternative for large baskets or trays of instruments and textile sets. They are offered in a vast range of different qualities and strengths. The porous and breathable surface of the materials allows unrestricted access of steam into the package. Heavy-duty metal or plastic containers can also be used for certain special-purpose instruments and sets. Specific instructions and restrictions are issued regarding the use of these containers. The instruments should not be packed too tightly. It's recommended that the packages should be filled to no more than 3/4 of their length, and 2 centimeters of empty space should be allowed around each instrument. For the purpose of autoclaving, the packages must be able to breathe. The powerful vacuum pulses used in the process can cause the seals to break open if the contents are packed too tightly. The pouch design provides a secure grip, which helps when filling the package. Pay attention to the opening direction marked on the packaging. The paper involves a specific orientation of the fibers, which is subsequently taken into account during the printing and pouch making process. The packages should also be opened in line with this fiber orientation to prevent the fibers from breaking and thereby possibly causing contamination. The product should be positioned correctly inside the package to enable easy removal of the packaging after it's been opened along the appropriate seal. Where double packaging is required, it's important to position paper against paper and laminate against laminate. The inner packaging must not be folded so that the passage of steam remains unhindered. The colored plastic film turns a darker shade where the sealing has taken place, making it easy to check that the seal is intact. The heat sealing equipment must be tested regularly to validate that it's functioning properly, and the test results must be filed as part of the quality system. A number of useful tools are available for testing. They have been developed to facilitate the daily assessment of heat sealing results and to speed up its documentation. If the heat sealer has an integrated printer, any labels or marking can be printed in conjunction with the heat sealing process. The Bowie and Dick type test is used to check and assess the efficiency of air removal and steam penetration. The test must be performed every day before using the autoclave. The tightness test, to ensure the chamber is airtight, should be run at regular intervals. To ensure an effective passage of steam, the products packed in sterilization pouches are placed in the basket, laminate against laminate, and paper against paper. If possible, the packages should be placed upright, using partitions if necessary. If it's not possible to place packages